minus 8y. We do not touch the 8y because we don't have anything to combine with it or simplify it down to. What's up, dude? So the only reason why we're combining these two terms is because they both have z. If this was a y instead of a z, what would we combine it with? No, if this was a y, we combine it with 8y, because they both would have y's. In this case, we have two things with z. We can scrunch the z's together, make them one term. What's up?
If it was a y, then it would add it to the subtraction. Oh, it would be y. It would be 6y instead of minus 10y
Because it's a negative.
yeah.
And that this is a positive 2. So it would be kind of like negative 8 plus 2, which would become negative 6. What's up?
Does this mean that like the final problem would end up being like z minus y?
Yeah, you would have 8z, because we can combine the z's, minus 8y.
So
Now, what you guys are kind of doing today, we aren't solving for anything, we aren't plugging anything in, as far as I know, into like a or x or z or y. All we're doing is seeing if we can get these expressions kind of scrunched down to their smallest form. So like with this one, we can simplify it. This one's already simplified, we can't do anything else with it. There's no additional x's, there's no other numbers to add to the 3. It's as simplified as it gets. And this one, as simplified as it gets. There's nothing else to combine with it.
do you always do number that comes first when combining?
Not necessarily, because the thing is if we wanted to move this 6z over to like here, you would have negative 8y plus 8z. You can move those around how you would like. The only thing is you have to make sure that negatives are traveling with the negative number, so the negative sign always has to stay with the 8. You can't do like, oh, I'm going to move this over here, something like that, and move this with this, and now this is like negative 8z plus 8y. That wouldn't be the same. You have to make sure that if it's negative 8y, the negative stays on that negative 8y, wherever it goes.
I think it's a subtraction sign, not a negative.
It is subtraction. Subtraction's kind of like turning something into negative. Because what you can do, you can put this in parentheses, and you can say that's a negative 1 out front, multiplying into the 8y. That's another way to kind of look at it. What's up?
Well, our teacher had us do like these blocks going through the same answer more than we'd like circle them or something like that.
Okay.
So then, and we put the operations still with it there.
Okay. Yeah, you guys can do that, and that helps you kind of keep track of the operations and combine what you want to combine. Yeah?
Yeah, so there was one time our math teacher, he said there's no such thing as subtraction, it's just adding negatives.
Yeah, basically, yeah. I mean, that's kind of the thing. We teach you guys subtraction so you know take away, that kind of a thing. It depends on what kind of numbers you want to look at or how you want to operate with them and stuff. Negatives become very useful later down when you guys are getting into like science kind of stuff, because now you're doing directions. If you know your x, y plane, that kind of thing, yeah, positives on this side, negatives on this side, yeah, then it becomes very, very useful. I know I just teed those in class. I'm sorry, guys. What's up?
So if you have a variable that's just, like let's say we had 8y and then we had 5, if you combine it and say y to the second power.
8y and negative 8y?
No, just 8y and then just y.
Oh, 8y and y. And you're multiplying them?
No, you're adding them.
You're adding them together? If you have a variable, let's say we have this a, right? And we take away the 5, we just have a. Do we still have a number in front of it?
No.
We technically do. It's invisible. It's a 1. If you ever see a variable that's just by itself, if it were just a, it's technically 1a. Because that's the only thing, is if we put a different number there, then we're changing it. Obviously, we can't just assume 2y, 3y, 4y, 5y, or a rather. But if we don't have any number there and we just have the variable by itself, it's technically a 1.
So we could just combine, it would just be like +1.
Yeah, so if this were just z instead of 2z, it'd be 6z plus 1z,
So
and that would become 7z. But since it's 2, it's 8z.
got it.
Okay. So I think we should probably move on to some examples. We've got a few here. We'll kind of focus on the first one up top. So we have 3x plus 2y minus x plus 5y. What can we combine?
You can do 3x minus x, which is 1. So you have 2x and then 2y plus 5y. So you now have 7y.
Yep.
So 2x plus 7y.
7y. You got it. That's its simplified form. Does that make sense to everybody? Awesome. How about the second one? Who wants to kind of help me get through the second one? You over there? Yeah.
7a plus 3a plus a is 12a.
Close.
11a.
11a.
And then minus 4 is minus 13.
Yep.
11a
So,
minus 13.
11a minus 13. You got it. How about the third one? This one's a little bit trickier. So yeah, you guys know the distributive property. When you have something in parentheses like this, and there's a number out front, you're like multiplying everything inside by that number. It'd be like saying 2 times 5a plus 2 times 5b, or 2b.
So it would be 2b and
Yeah, or it would be, 10a and 2b. Yep. And then, what about this one? What would this be?
2a.
Not 2a, 3a
Subtract 6b.
minus 6b. You guys got it? And then from there,
you can still simplify with the b into b2 subtract 6b.
so 2 minus 6 is negative 4.
And then you do the
10a and 3a, 13a. So 13a minus 4b, or negative 4b. You're kind of like saying minus, because that's how the expression goes. But yeah, I think you guys are got it. We're on a roll. How about this one? What do we need to do first?
subtract the 7.
Don't do that first. Do you guys know about PEMDAS?
X plus 1.
That whole thing? Who can tell me PEMDAS? What's the first term in it?
Parentheses.
Okay, yeah, sorry, if I say like this kind of thing, maybe if I do this, what's up? If I do like this, then I guess you guys can all answer. If I point to somebody, then that person answers. But yeah, parentheses. So, we have parentheses. We got to look inside it for one thing first. Can we combine x and y?
No.
Nope, we can't do that. So we don't have to worry about parentheses. What's the next one? E. Exponent. Do we have any exponents? Nope, don't have to worry about exponents. What's the next one? Multiplication and division. So they're kind of like on the same plane. You can treat them as equal. So, at the top of the hierarchy, you have parentheses, then exponent, then multiplication, division, and then addition, subtraction. So if multiplication, division are higher up than addition and subtraction, do we subtract these first? No? What do we do first?
Oh.
4
You do 7 times 1 is y.
You do 7.
We do x.
Can you tell me? Yeah. Sorry, anyways. Yeah, you in the green. Sorry. I don't know names.
You add the y to the 7y, right? First, and then because you can combine it.
Well, remember, it's in the parentheses. This one's in the parentheses, and that one's outside. We can't touch it yet. We have to get this one out of the parentheses, but we have to do something to it first to get it out. Can you tell me in the purple and white?
So, I think it's 4 times x and 4 times y.
Yes.
4x and 4y and then
the thing is that we also do have this negative here. This is going to tag along with this 4.
So that's a negative?
Yep. So if it's subtraction, it's like negative. You can take the subtraction sign and just kind of cap it onto the 4, and then you can carry that through the whole problem. So what would be negative 4 times x?
Negative 4x.
Negative 4x, and then negative 4y. So we have 7 minus 4x minus 4y. So just remember that the negative does carry all the way through. So if we have 7 minus 4x minus 4y, minus 4y plus 7y, 3y, and then negative 4x, negative x,
Negative 5x.
negative 5x. So yep, 7 minus 5x minus, or plus 3y.
It's confusing when you can't write it.
Yeah, that's the thing. Might have to improve
If
this.
you want, you can roll up the projector and you can write.
Are you guys okay with that? Can you see everything just fine?
Yeah, we can still see on the.
I have no idea where my glasses went, so I can't.
You can see, that might be good. Markers. Orange. Doesn't look like there are. Do you guys have any markers?
Usually, the stage brings them, or she asks the custodian.
Okay.
Or you.
And, okay, that'd be good.
Can't read it.
Yeah, that's the only thing. Now we can't read it. Okay, I might do it over there then, but I'll try to write it. So we'll just move on to some of the next few. What I'd like you guys to do is we walked through the last few together. We went through the first slide that kind of explained the expressions and what they are. Then we went through some slides where we did it together as a class. So with these ones, I'd like you guys to kind of do it on your own. If somebody has an answer for me, you tell me what it is, I will write it up on the board and we'll double check. So once somebody has number 1, just go ahead and tell me.
9a plus 2b minus 4.
Yes, that's right. Okay, what about the second one? Of course, this is the most garbage marker in the entire planet. Sorry, what did you guys say for this one?
14x minus 4 minus 9. Well,
Minus
5. 14x minus 13. Yeah. Right?
Yes, that's right. Who said this one?
Me.
You got it.
I got both of them.
Because 6x plus 1x is 7, plus another 7, that's 14. So we got that here. Negative 4 plus negative 9. So combine 4 and 9, we got 13 minus 13. We got it. What about number 3?
13 plus negative.
Hold up, guys. Sorry, I saw somebody raise their hand and I want.
Wait, never mind.
You all got it?
13 subtract
13 minus just b. Okay. So if we have 3a, or 3 times a minus b, that'll be 3a minus 3b. And then on the other end we have our
NA subtract or NA plus CB.
plus 10a plus 2b. Does that kind of make sense to everybody how we're getting to here? That we're just doing distributed property. 3 times 1a is 3a. 3 times negative 1b is negative 3b. Plus 2 times 5a, 10a. And 2 times b is 2b. So that's what we got right here. And then combining the like terms, we have 3a plus 10a, should be 13a. And then negative 3b plus 2b, which is negative 2. Anybody have any hiccups about that, or are we all good?
We all good.
Okay, then I think we're all good. Guys, you guys don't have any markers in this room, or any erasers or any. Oh, there's an eraser right there. You guys are tall. All right. Four. That's a tall. All right, number 4. You guys take a look at that, and somebody tell me number 4 is. Okay. Not plus 6. If anything, write it out on your paper. Do the math. Sometimes do it in your head. I mean, even it can get hard for me to keep track of all of that in my head. So why don't we kind of walk through this one just a little bit. We have, what do I get if I multiply 6 and x? 6x. And then what do I get if I multiply 6 and negative 4? Negative 24. Remember the negative. That's important. That's going to change a lot. Negative 2 times 4x. Negative 8x. Negative 2 times 6. Negative 12. You guys are on a roll. So combine like terms. What can we combine?
So we got 14x negative. Isn't it negative?
So a negative 24 and a negative 12.
Negative 2.
What would be negative 2?
6x subtract 8x. Negative 2.
Oh, sir. Yeah. I heard somebody say 14, but yeah, it's negative 2.
And then would it be negative 36?
36. Does that make sense to everybody, combining like terms? Because you guys are going to have some homework, we're going to have some games, so I hope everybody's all good on this. If you have any questions, now's the time to ask. And don't be afraid, I don't know. Not too much. So how about number 5?
Number 5 is 9. Wait, no.
So we have a 9 minus. Wait a minute.
Would that be 8x?
Well, let's cover real quick what this means. So if you ever have just a subtraction sign outside of the parentheses, do you know what that does to everything inside the parentheses?
Make it all negative.
Makes it all negative, because you know what's technically out here? A negative 1. So it's just like negative, or 9 minus 1 times x plus 6 plus 3x.
Would it be negative x? Or just negative x?
Yep. 9 minus x. And then what is that? What's the 1 times the 6? The negative 1.
Negative 6.
Negative 6.
And then
We still have 3x.
when you add the 3x, it's going to be the 2x. Negative 2x.
What's up?
So in that one, what if the plus in the parentheses was a negative?
You confused about this?
No, if you do negative 1, like if the never mind.
Okay. Like I said, if you guys have any questions, I'm not afraid to answer. Oh, are you talking about the last one?
No.
You talking about this one?
Yeah, because the 9 subtract 9 subtract no 9 subtract -6.
Well, plus -6. Because if you did 9 minus -6, that's like 9 plus 6. But if you guys even want, if it makes it easier,
Oh, it's 3.
yeah, if you guys want to, you can arrange the like terms right next to each other without changing the problem. As long as you keep the signs out front of everything out front. As long as you don't alter the signs and you keep them grouped up with whatever variable they're next to, or whatever term rather, then the equation will be exactly the same.
And that 3 plus
So this will be 3
plus 2
plus 2 what's?
x.
2x. That one all simplified down.
Hey, wait, wouldn't the 2 be negative? Would it be negative 2x?
Um,
No, the 3 subtract just negative.
yeah, that's the only thing. So we have a negative x and a positive 3x. So it'll be basically like 3 minus 1. Yeah. Any other questions before we kind of move on? Good? Sweet.
What about number 6?
Then number 6. Give me a second to just clear the board. This marker kind of stinks and this eraser kind of stinks.
We both kind of stick.
I need to go bring my stuff to my room next time if this ever happens in the future. What's up?
I know number 6.
Okay.
It's negative 3a plus negative 3b.
Or, so negative 3a and negative 3b?
Plus negative 3b.
Yeah.
Well, just basically.
Yeah.
But that works. So, let's just double check that. We have 5a,
And
negative 3 and a,
Negative 3.
negative 3a, negative 3b. So,
and the 5a and 5b. Wait.
so we have,
Oh, I
5A.
thought the 5b
So
was
that's
5a.
negative 8b.
So I canceled them out.
Negative 8b.
I thought the 5a and 5b
2a.
were both the same.
Isn't it 2a subtract negative 5 or 8b?
yeah. So this is
Not
2a
2a, is 5 minus 3.
negative 8b.
And then, yep, since they're both negative, we can just kind of put them together. So you have 2a minus 8b. So as long as you guys are kind of getting most of these, then we'll probably be pretty good. So,
I'm a little confused on how you got 8B.
so let's not worry about the a's, we'll just focus on the b's. So negative 3, remember we have to distribute it into the parentheses. So negative 3b, what does that equal? Negative 3 times b,
Negative 3B.
negative 3b. And then we also have a negative 5b on the end already. We have to pay attention to. So if we have negative 3b minus 5b, what do we do with two negatives?
Like on the positive.
If we're like subtracting a negative, something like that. But the thing is this is kind of like negative 3b, like somebody pointed out earlier.
So that cancels it.
So this won't cancel out. If we have a negative 3b plus a negative 5b, then that won't become like positive. If we had minus a negative 5b, something like that, where we have a negative outside of the parentheses and we have a negative inside parentheses, then it's kind of like, remember I said there's like a negative 1 just chilling out here? And that's going to get distributed in. So what is a negative times a negative? positive. Or a negative subtract a negative, something like that. So this is, without the 1, this is a negative subtracting a negative. With the 1, it's like a negative times a negative. That's why they're both kind of flip-floppy. You can go either way. Either way that you want to use to figure out that that's positive. Yeah?
How Miss H explained it was that if you have a negative in front of a minus, subtraction sign minus a in front of a negative in parentheses, then it's like the two negatives just squished together to form a addition sign. So really, what I like to do is I just draw like a V below them, and I put it. So if you just draw two letters, and that's basically what it is.
Okay. Yeah, and that kind of works too. You're recognizing that you've got to combine the two into a positive. Any more questions? Sorry, I'm seeing some people with kind of hands up. Put your hands up higher. Okay. So, as long as we kind of understand that, because I know some of you guys have been going over some of the positive, negative stuff. If we have any issues or any confusion about that, we can double check it up on the board. And we'll get better and better at it with time. We're doing good. Yes, we actually do. Let me get this cleaned up. We've got our choice between 3 different things. I've got a slide for it, so I'll put that up on the board. We can't nap. We must come in.
Is there a want to now?
No, not. Sorry, we can't do that today. That's just what Miss Hasty wanted. And this keeps chaos to a minimum, which I appreciate. So games. We have a few games to try. It will help us practice the expression simplification. Now, you guys, I'm going to have you guys vote in batches.
What is square root?
I have a question.
Is it the game where you have dots and you try to make squares?
What's your question real quick?
Are we supposed to turn in page 9 today?
I think so. I want to say Robin's going to check that for you guys. So, when it comes to the games, I'll kind of explain the rules. Obviously, you guys know tic-tac-toe. Get your X's and O's. We're doing it with math. You don't know tic-tac-toe?
Hold cats.
So, if you guys know tic-tac-toe, obviously 2-player game, you guys will pair up with people next to you or right behind you, something like that. And it's basically like you're doing an equation in a box. Once you've done an equation in that box, you can mark it off with your X or O, depending on who you are, and we'll see who wins that game. And then I'll say this, if you guys win, I have candy upstairs. I don't mind giving you guys a piece of candy. I will keep track of winners. So, that's one game that we can play 2 players.
What's square up?
Then we have square up. Square up is we have a grid of, I think, 25 squares, something like that. So kind of like think a checkerboard, right? It has a bunch of problems in it. You guys, it's not like tic-tac-toe where you have to wait for your opponent to make their move and then you make yours. Square up is you keep going, you keep going. You see a problem in a box, you do that problem. If you solve it correctly, you color in that box. I have colored pencils up here that I will give you guys. You choose a color, your opponent chooses a color, whoever ends up with most boxes at the end wins. So that's square up.
Can we just do our homework?
Yeah.
I guess if you guys want.
Well,
You don't want any candy, you don't want to do any games.
What is our homework?
Okay. So, Miss H said that if we were assigned to a weekend, we were fully allowed to get some. She didn't want us. She did say that, and even if she did get some, we didn't do it, it would have affected her grade.
Okay. I don't know how it necessarily works. I'm just telling you guys. I can't email her, but that's the only thing. I can't. I'll email her, and then she can probably send you guys a message on Canvas. She will clarify it to you guys. Because I'm not totally in charge of that. I'm not 100% sure about the rule. I just want to let you guys know this is what I think is happening. If I'm wrong, she'll let you know. That's what I mean. I will email her. I can probably do that after this class. In your guys' study hall, I will email her. Because she's busy doing other things right now. But she can get back to you guys. That should be a big deal. So, and then if it's due over the weekend, like I said, if I get to her today, then maybe she gets to you guys by Friday at the latest or later tonight. Yeah. Then at the very least you'll know, and then you either have a free weekend or you got one thing to do over the weekend that's like 10 problems, I think. Yeah, some of you guys have already blown through it. It's super simple. So it's like, oh my gosh, I have to do this 10 problems. It's painless. We'll get through it in a minute. So, okay, let's take that code, let's square up. Now hang them in. All of you guys will be in a group. And if you guys get it, before I don't know if you guys know how hangman works.
Before the man gets hanged.
So, I think the rules with this one in particular is we draw a man, we do head, body, arms, legs.
I'm gonna go like this.
They give me specific rules. Yeah, they give me specific rules on how many turns you guys have. And that's me drawing the parts on it.
What about the scruff on his beard?
The scruff on his beard? Sure, I can draw the scruff.
Yeah.
Yeah, we can make it look fancy, but obviously the rules of the game where you don't want to get the man hanged. So, if we do hang the man, then you guys are doing math.
And you get
Once you do the math and you get an equation, you get to choose a letter.
like if we get wrong pass.
If you get it wrong, then you don't get to choose a letter.
We go the whole pass. Yeah, we the whole pass. Why not get
Do you guys want to go, how about this? I will give you guys a choice. Double or nothing. Everyone in this class, if we do hangman, everyone in this class, if we get through it, gets 2 pieces of candy. If we want to go by the rules, I don't have the marker here. If we go by the rules that you guys are doing the equations for the hangman, right? When somebody has an answer, and I want to see all of you guys participate, not just 2 or 3, I'm the smart kid, I'm going to do it. Everyone's going to participate.
No.
And, yeah, maybe I can do that. How about those of you who actually participate get the candy? If you don't, sucks to suck. But, if you guys participate, if you want, we can do 1 piece of candy. You play regular hangman. If you get the problem wrong, trying to get a letter, because if you get the problem right, you get a letter. If you're wrong about the letter, I add to the hangman. If you guys are right about the letter, I add it to the board, and we spell out a message. And then whoever can guess the message, I'll give you 3 pieces of candy.
Everybody still get one.
What if lots of people?
I gotta just
Double or nothing? Well, I'll say if you participate, you get it. So everyone can participate.
So if you participate in
Then you've secured your 2 pieces of candy.
I have a question.
What's up?
What if lots of people get the answer, but you only call on one?
Well, I said I will try to call on different people. If you've already given an answer, I'll say that you've secured your 2 pieces of candy if we win.
Yeah, but
Then
the
you're
person who
good.
guesses the answer gets 3 pieces of candy. What if lots of people get
Everybody goes on.
How about, yeah, whoever guesses the answer, okay. In the name of fairness, whoever guesses the answer gets 3, because they guess the answer. Everyone else will get 2.
Okay.
So if you want to be the hero, go for it.
Mr. Whitney,
What's
there's
up?
26 kids in our class and 26 letters in the alphabet, so we could all just guess the letters.
You're going to get that man home. Just go for that. You need to be careful. Yeah?
Somebody could just wait until the 12 solved.
Yeah, I think we should just do double nothing.
Okay, we can do double or nothing. That's fine. And then if we do win, everyone can get 2 pieces of candy. So, are we happy with that? Okay, which games do we want to play? I want to show a show of hands. Who wants to do 1 first? Okay, we've got a few people that want to do tic-tac-toe. Who wants to do square up?
Wait, I swear up.
I just explained the rules earlier. If you weren't listening,
Too bad.
okay, a couple people want to do square up. How about hang the men? Who wants to do hang the men?
Hey, is this gonna be
Okay, I guess we want to do hangman.
No, we want to do square
How about this? If you guys want to do tic-tac-toe,
Good luck.
we can put you maybe in the back row, something like that. I will say, who wants to do tic-tac-toe? Do we have an even amount of players? We need 4 players. If we have 3 people, we need 4 players. Are you playing?
Me?
Yeah?
No way.
No?
No way.
So we only have 3 players for tic-tac-toe. Does anyone else want to do? I think she's busy doing other things, if anything. You'll do tic-tac-toe? Okay. You guys,
There's a couple kids who want to do square up too.
yeah, I saw that too. So, one square up, and there's 4 of you guys that want to do tic-tac-toe. I will allow you guys.
Are you both of you going to do square up?
I will allow you guys to sit next to each other because 4 of you guys want to do tic-tac-toe and 2 of you guys want to do square up. You 2 wanted to do square up? Okay, you're right next to each other. You're all good. When I say go, you guys can go. Yes. You want to do tic-tac-toe? Okay. What? You don't need any participation. If we win tic-tac-toe, everyone gets 2 pieces of candy. Everyone gets 2 pieces of candy. So there's tic-tac-toe. Or, sorry, you were the guy that said you didn't want to. So those of you that wanted to play tic-tac-toe, guys, those of you that wanted to play tic-tac-toe, you can sit up amongst each other, and then those 2 that are playing square up, they're already next to each other, they're good. Everyone else who wants to play hangman? Let's do some hangman.
Boston, you can sit here.
I'm going to bring my kid on.
Okay, I think that's... Who wants to all participate in this row hangman? Maggie,